A warm welcome to all the viewers. In this video, I am going to quickly tell you how to import data and build your first model in ONYX-SEM, which is a free software for CB-SEM analysis. You might like to go back and check my previous video wherein I have told you how to download and install ONYX-SEM on your Windows PC effectively along with Java JDK file which is required to be run in the background so that your computer executes ONYX-SEM flawlessly. So now let us go to ONYX-SEM and see how we build our data and what type of data files can be imported. So here we are in our ONYX interface. You go to ONYX and then you go to load model or data, and it basically takes .csv, .dat and .sav files, which are the files imported from SPSS. You can directly take the files from SPSS and import them. Here I have an example where I have behavioral intention datasheet.csv. I click on that and click open. As soon as I select that file, you see the file is open, behavioral intention datasheet. It has 204 observations and 25 variables, case ID, occupation, gender, and then I have 4 indicators of food quality, FQ, 4 indicators of cultural authenticity, CA1 to CA4, 4 indicators of service quality, that is SQ1 to SQ4, 4 indicators of value for money, VM1 to VM4, determining the dependent variable, which is behavioral intention, having 4 indicators. All of them are reflective in nature. We must know that ONYX is CBSEM based software. It works for CBSEM analysis and not for PLS-SEM. So the same parameters, the metrics which you use to evaluate the measurement model and structural model in IBM SPS AMOS, we use the same metrics over here like RMSEA, CFI, NFI, TLI. So I'm going to discuss all those with you. Stay tuned and keep watching. It also works on the same principle of maximum likelihood, MLE estimation. Now to create a model, I right click on the canvas and say create new model, create empty model. It will give me a blank space like this. In this, I need to bring in my indicators. Say I want to bring in the indicators of food quality FQ1 to FQ4. I click on FQ1 and by pressing the shift button, I go to FQ4 and select all of them and bring them on the canvas. Once I brought them on the canvas, I can see the error variances of each indicator over here. These are the error variances. Now I need to draw a latent variable, food quality. I click on latent and you get the latent variable, that is food quality. Now once I've got this latent variable onto my sheet, I need to connect it to the indicators. How to connect it? Right click and drag. Right click and drag. Again the same. So you get these reflective indicators, the arrows pointing from the latent variable to the indicators. Once I've done this, what I need to do next? I need to fix in the parameter of latent variable, just like we used to fix the parameter on one of the indicators in IBM SPSS MOS. Here in ONYX, we have to fix the parameter of the latent variable. So I select this and click on fix parameter. So I got this value 0.42. Now what next I need to do? This is a sequential process. So the way I'm showing you step by step, you have to conduct it like this only. And do check that it's maximum likelihood estimate best selected over here. In case it is not, you can right click and then go to estimation. And you see here show best ML estimate. This has to be ticked. Now to see the factor loadings, what I need to do, I select all the arrows, right click, and then free parameter. We have to free these parameters. Now whatever I see over here on the canvas right now are unstandardized factor loadings. These are unstandardized factor loadings. I want them to be standardized because that has to be used further for assessment. So I select all of them once again and right click and say show standardized effects. Now you see within the brackets, inside these round brackets, you see the factor loadings, standardized factor loadings. This is 0.74, this is 0.9 for food quality 2, food quality 3 it is 0.85, and food quality 4 it is 0.59. Now this is how you build, you construct the latent variables, bring them onto the canvas. Similarly, you bring in all 5 constructs in your model and then draw covariances between them, just like we used to do in IBM SPSS AMOS, and then assess the measurement model. Assessment of measurement model deals with the assessment of certain parameters, certain metrics, which are RMSEA, SRMR, CFI, TLI, and NFI and GFI, which I'll be talking about in the next video, wherein I will show you how to conduct confirmatory factor analysis or measurement model assessment in ONYX-SEM. Stay tuned for more. Keep watching. Thanks a lot.